Okay, guys, how's it going? Okay, section D. Hopefully I talked about it with your class a little bit. If not, this is the algebra section, pretty big. Okay, first, what do we have over here? We have 4 times 5x, which is 20x. We have 4 times 7, which is plus 28. And then we have minus x. So really what we have on this side is 19x plus 28. Okay, so we have some other side, right? Now we have 3 options. Let's say we want this equation to have one answer, like a normal problem. Let's say we want this problem to have infinity solutions, infinite. Let's say we want this problem to have no solution. What do we need? So this is a big skill that they want you to have at this level. So if we want this to have one answer like a normal problem, then we just don't want the x's to cancel it out. So we just want to make sure we have something different than 19. So I'll choose like 7. 7x plus anything, plus 8. That'll have one answer. When the x's don't cancel each other out, that's normal. What about infinity? Infinity means you have exactly the same. So you have the same amount of x's, and you also have the same amount of the back. 19 plus 28. If I want no solution, what am I going to do? I want the x's to cancel themselves out, but I want the back numbers to disagree. Like 28 does not equal 14. So that's no solution. So for infinity solutions, you need the same amount of x's. For infinity, the back needs to be the same. For the front, it needs to be different for no solution. So hopefully you guys remember us talking about that in class. Normal problems that we've been doing all year are when you have different amounts of x's. All right, number 2 is actually kind of easy once I noticed what it was. Can 9x plus y and y plus 9x, which is just 9x plus y backwards, right? Could 9x plus y equal negative 55? And could 9x plus y equal negative 23? Is that possible? Can the same thing equal 2 different answers? I think I just gave you your answer. Okay, let's see. I don't even know what that was. Okay, these are select all that have no solution. So we're trying to get the same amount of x's on both sides, but different back numbers. So let's see what we have here for A. A, if I put the negative into both of them, I have 20x minus 10x minus 6 equals 7x. 20x minus 10x is 10x's minus 6 equals 7x's, and I could say plus 0 if I just want to compare these. These have different amount of x's on both sides, right? There's not the same amount of x's on both sides. So this is normal. That's a normal equation. I could solve that. That's easy. So this is going to have one answer. So is this a no solution? No, this is not no solution. What if I look at the second one? Like 11, let's see, I'm going to combine this 12x and minus 4x and say 11 plus 8x equals 5 plus 8x. Oh, look at that. Same amount of x's on both sides. They're going to cancel each other out. 8x's and 8x's. See ya. So now we have the equation 11 equals 5. Is that true? That is not true. So that's no solution. So notice what I did. If they have the same amount of x's and the numbers at the end are different, it's no solution. I'm going to let you do C and D by yourself because we have 16x's minus 8x's on this side, and then we have 15x's minus 5x's on this side. You should be able to tell what those are. Let's see. A system of 2 linear equations has no solution. The first equation is 3x plus y equals negative 5. What's one that will have no solution? Well, let's see. If 3x plus 5 equals negative 5, could 3x plus y equals negative 5? Is it possible that 3x plus y also equals 7? Is that possible? All right, let's see. Number 4. Enter the x coordinate to the solution to this system. Okay, so this one is elimination. What I'm gonna do is multiply the top one by 6. Why am I gonna do that? So I can have positive 6y and negative 6y. So everything on the top, I'm gonna multiply by 6, everything. And I'm gonna have 30 x's plus 6 y's equals negative 48. The bottom, I'm just gonna leave the same. X minus 6y equals 17. Now I'm gonna combine the rows. 30 x's and 1 x is 31 x's. The y's cancel out. So I'm gonna just put a box around them, but see you later. And equals negative 48 and positive 17. The negatives win by 31. All right, so we divide by 31. And x's equal negative 1. So there we go. We know what the x's equal. So if you're an honors kid, you probably would have got that without my help. If you're not, that's probably pretty tough. I just want you to see it. All right, a system of two linear equations has no solution. The first equation is x minus 2y equals 18. Select the second equation that would have this be infinitely many solutions. Okay, let's see. So x minus 2y equals 18. Okay, sweet. Are any of these versions of that, like infinite solution means it's really the same equation. Are any of these the same equation as that? Let's see. Let's rearrange all of these equations. This is a pretty tough problem, and we've never really done anything like this in class. Let's rearrange this one. So let's put the x's first. So we'll put this one down here, and we'll put this one in black. Negative 3x plus 6y equals 54. Oops, 54. Let's put this one in red. Let's see if any negative 3x plus 6y equals 54. And we'll put this one in blue. Negative 6y plus 3x. Oops, I'm going to put the x's in the first column. 3x minus 6y equals 54. And I'm going to put this one in green. 3x's minus 6y equals 48. Okay, we're trying to see if they're infinite many solutions, it means they're really the same equation. Let's see. 18 times 3 is 54. So what if I happen to multiply our original equation, this guy up here? What if I multiply him by 3? Then I'll get 3x's minus 6y's equals 54. Oh, that's that one. So they actually were the same equation. This one was just 3 times bigger, and they tried to hide it by rearranging it. But this one is actually just, all the numbers are 3 times bigger than that. So they're actually the same equation, and that's why there's infinite many solutions. They're exactly the same equation. Tough problem. Number 6, enter a number into each box that will give this exactly one solution. So normal problem. If we do this times this and this times this, we have 24x plus 32 minus x. So we have 23x plus 32. If we want this to have one answer, just have it be a normal equation, what does the x's have to be? If you said it has to be 23, you're absolutely wrong. If you put the same amount of x's, this is either going to be infinity or no solution. So actually, you can put whatever you want in this box, doesn't matter, as long as this box is not 23, any number but 23, because then they won't have the same amount of x's, and they'll just be one normal answer. All right, see if you can do the same thing for the next problem, but so that they're infinity amount of answers, so that they're exactly the same equation. The front and the back are the same. All right, and finally, a tree that is 6 feet tall is growing at 2.5 feet per year. So let's see. It's 2.5 feet every year, but it's starting at 6 feet. Okay. A tree that is 16 feet tall is growing at 1.5 feet a year. So it's growing 1.5 feet every year. I'll do it in a different color. 1.5 feet every year, but it's starting at 16, so plus 16. When will those two be equal to each other? When are they going to be equal? So we'll just say those two equal. When does the tree that starts at 6 and grows 2.5 a year, when is it equal to the tree that starts at 16 and grows 1.5? All right, so if this is old, here's an X team, here's an X team, here's a number team, here's a number team. So I'm going to subtract 1.5x from this side and move it over here, minus 1.5. I'm going to subtract 6 from over here and subtract 6 from over here. See ya. 2.5 minus 1.5 is just 1. So x equals 10. After 10 years, they're going to be the same. So if you could do that by yourself, great. If not, this was a very hard section. Very hard section. You see that they want ones, infinity, no solution, and one solution. They want you to know that. All right, good luck. Later.